Hi Joyce, so the kiddos are working in their notes on 2 examples, trying to figure out these 2 alternating series, whether they converge conditionally, absolutely, or diverge. So they're playing with endeavor number 19, and then we made the absolute and conditional convergence from Friday, endeavor number 20. Trying to use them both in tandem, in conjunction, in order to see what they can learn about these 2. The rest of you guys were also asking questions. Let's peek at the calendar real fast since I have it up, as to what the schedule is like. I have test corrections and technically quiz corrections. Oh, struggle. Don't worry, I got you. Test corrections, and it was supposed to be quiz corrections. I have it due today. Whatever, I'll take it by tomorrow. I'll just make sure it's back there in the tray. Both our Chapter 9 test corrections and then 9.1 to 9.3 quiz corrections by tomorrow. We're continuing 9.5. Might still be finishing it tomorrow. We'll see. We might be able to start section 9.6. 9.6 is as far as we are going. But there is going to be a pretty big Forever Endeavor quiz on Friday because we have all these new tests. Actually, it'll be on all the tests, 9.1 to 9.6, and there's a couple extra things. For instance, the absolute and conditional convergence for alternating series. So there's going to be a big old Forever Endeavor quiz, meaning like 10 points, not, but like printed out, multiple questions, maybe 15 points. Then we'll do homework questions. We might also do the Chapter 9 AP questions on Friday. That Chapter 9 AP is technically due on Monday, but we might have a little bit of time to go over questions that we have on it, or to have maybe like a half work day on Friday, depending on how long the Forever Endeavor quiz goes with all the tests, and depending on how long homework questions go. Then we have our test on Tuesday. Sound good? Test meaning 9.1 to 9.6, our Chapter 10 intro. Okay, so let me go ahead and get out of that because we don't need that anymore. I don't think we need this either. Why is that open? I don't know. Okay, let me come on back to our examples. You guys had both of them attempted?
Yes.
Okay. So let's go ahead and see what you guys were able to do. Ugh, I'm just going to put my foot there. And once again, you guys all have your green sheets for your AP test, right? Okay. Do March 1st? Something early March. Okay, for number 1, what did you guys think of doing first?
The limit.
Okay, the limit as n goes to infinity of 1 over n? Okay. And of course, limit as n goes to infinity of 1 over n is equal to 0. Now that is only enough for me to say that this converges conditionally. Now we know right away it does not diverge, right? Not for this example. But how do we check to make sure it doesn't converge absolutely instead?
Yeah, what about the second part?
Oh, sorry, second part is that the terms are decreasing. Is it absolute value of the terms? Oh, the a sub n.
A sub n plus 1 is less than or equal to a sub n.
So 1/2 is less than or equal to 1.
Why do we need to do that if we know that the series diverges if the limit does not equal 0? You know what I mean? Yeah. Does it have to equal 0 and the other one? You know what I mean? Like step 1 has to be good and step 2
Like,
has to be good.
is there a way for it to equal 0 and not have decreasing terms? Is that what you mean?
It converges. So like,
I feel like it wouldn't be possible.
1 is true, 2 is false, but it's still convergent. Yeah, I think it's not possible.
Because the bottom has to be greater in order for the limit to be 0. And if the bottom's greater, then adding to the bottom is going to make a sub n plus 1 smaller.
Okay. There is a reason why we have to think about this, so hold on to that. Remember how some things go up and then go down? And how we kind of have to separate the first 2 terms from the rest of the series that we determine the convergence or divergence by? Alternating series, there's something called the alternating series remainder theorem, where we can approximate the sum of an alternating series using a theorem, but we can only do that if the second condition is true and if there are no initially increasing terms. Does that make sense? And so we're going to we're going to, if we have any of those funky sequences, series, we're going to have to separate the terms and find the approximation of the series, add it to the first 1 or 2 or 3 terms that increased initially. And I think that's mostly why the second thing is here. So when we determine convergence or divergence of alternating series, the terms have to be decreasing the entire time. And remember in that one homework, the integral test, we found a few where it did initially increase and then decrease. I think it was based on ln. ln messed this stuff up just a little bit. So it does make sense what you guys are saying, that eventually the terms are going to have to decrease, but that warning is there for what might be coming in any of those terms that initially increase then decrease. So let's come back.
Well, can we just write in parentheses terms have to be decreasing?
Sure.
No, I have it the wrong way, don't I?
Yeah. Would you
How, is it written a sub n, or is it written a sub n plus 1?
A sub n plus 1.
Okay, so we could say 1 over n plus 1 is
But
less than or equal to 1 over n. Okay. So both of those are check. That's only enough for conditional convergence. How do we test for absolute?
The limit as n equals to infinity of absolute value of 1 over n. Is that how it works? Or which?
Yeah, it's an absolute value
Add 1 over n.
Yeah.
and diverges.
So,
But wait, it's not the limit.
The series diverges by the nth term test.
No, I know, but I know.
B series.
Give me a second. Give me a second. What I was saying is that we're not trying to do the limit of the absolute value. We're just trying to test the convergence of the series. That might have been understood, just we need to go ahead and be particular. So we're trying to figure out, okay, if we take this series from n equals 1 to infinity of the absolute value of negative 1 to the n plus 1 all over n. You guys are right, that does, because it's 1 over n.
we just need the negative 1 and all that. Yeah.
I mean, the absolute value could say the exact same thing as, oh, I know who that is, that's 1 over n. I was just trying to show.
Isn't he just asking for a sub n? I'm confused with this whole thing. I'm not even sure what a sub n is.
Everything
A sub n-
except
Okay.
for the negative one.
Right,
In
so we
this-
need to put that in our
Okay, hold on. Usually, a sub n is the entire nth term formula, including the negative 1 to the power. Usually, a sub n is the entire inside part. If you would like, for the alternating series test alone, you could define a new b sub n. If you would like to keep them separate, you could define a new b that's separate than a so you don't get confused. And when we're talking about b, we're talking about the non-alternating sign component of the nth term formula. So technically this whole thing, technically from what we've seen from the very beginning, is a sub n. What they were trying to do is just, in each card separately, simplify things by not assigning a new variable, but either way, whichever way works better for you, you can assign the separate little piece apart from the sign, the alternating sign component, to be a separate letter, and that's totally fine, if that helps. Or you could just see these cards as related but separate to say, hey, this one starts with negative 1 to the n times a sub n, so I'm thinking for this entire card, this is referring to the non-alternating sign component. But once we come to conditional and absolute convergence, maybe we could state something at the very beginning where we say a sub n is equal to, for instance, negative 1 to the n b sub n. If that helps. A sub n is the entire thing, whatever is in there. Sometimes it's a negative 1, as I said before. Sometimes it's sine of pi n or cosine of, cosine of 0? That doesn't make sense. Cosine of pi over 2n. Anyway, I think I have that backwards. So it's up to you. Just realize in this one, this is the entire series like we're used to. Otherwise, there'd be no point for the absolute value, right? If we took away the negative positive component. So if that makes more sense, let's come on back. And so for absolute convergence, we're looking at the absolute value of the whole shebang, which is the same thing as, you're right, just the 1 over n. We're looking at the convergence, divergence, not just the limit. And yes, this one does diverge by what Gerardo already said. P series is the easiest one. Some of you guys were doing like integral tests and whatnot on your quiz, which is fine. I just think it's easier if you do P series, right? P is equal to 1. So therefore, since both of these are true, what can we say?
Misty.
Give me
On the
1 second. By the alternating series test.
Since the limit as n approaches infinity of 1 over n equals 0.
Mm-hmm. And 1 over n plus 1 is less than or equal to 1 over n. And the
Would you want to
series.
say a sub n is decreasing?
Faster, you have to say faster.
You can say decreasing for the entire sequence. This a sub n plus 1 returns, so I'm kind of just trying to get you used to the notation now. Returns in Taylor-Maclaurin polynomials, which are the next chapter after this test. The series converges how? No. Why absolutely? Oh, sorry. You're right. I'm getting too distracted over here. Converges conditionally. And technically, you could rewrite all the stuff we just did, but since we have all the rationale up above, we can say, hey, therefore, dun 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 dun.
And that would be okay on the AP
Yeah.
test.
That would be okay on the test. On the AP test, remember, I'm not exactly sure if they test your rationale on these parts specifically, but these do come into play, the harder parts, which I have seen on the AP. But for my test, that's kind of our immediate. That would be sufficient because you show me all the rationale as to how you can conclude converges conditionally. Now, number 2.
Wait, Misty, question.
Yeah.
The 1 over n plus 1 is less than or equal to 1 over n. How do you know that?
Because the denominator on the left is bigger than the denominator on the right, which means the entire thing on the left is smaller than the entire thing on the right. Remember when we were doing comparison tests, we had to think about bigger and smaller, and one true mark is if equal numerators, looking at their denominators, the larger denominator makes a smaller number, and vice versa. The smaller denominator makes the larger number. For number 2, this one's pretty easy because as soon as you do the limit as n goes to infinity, what do you guys get?
Divergence.
Yeah, we can just say of 2n cubed. And we don't even have to worry about conditional or absolute because whatever, which does not equal 0, series diverges. And technically, couldn't we just say that by nth term test and not even need to use alternating series test?
Yep.
So we could say if you wanted to give a rationale, yeah, we could say just nth term. Because I think nth term doesn't have to do with just positive terms, right? If you guys go back and check out your forever card. Integral test has to be positive. Comparison tests have to be positive. P-series, I don't think it really matters.
But wouldn't this fluctuate between -2 and 2? For the limit?
Yeah, so then the limit, we would say technically does not exist. Oh, I see what you're saying.
Yeah, the limit doesn't exist.
But
Therefore,
it's not 0 either way.
Yeah, it would limit D&E, so because the nth term test, series convergence. George, is this your pen?
Okay. Oops. There we go. How many examples do we have? Ooh, we have some good ones.
She says that, and I feel like they're going to be really, really hard.
Okay, our goal is to get all the way up to the estimation of alternate series by the end of class. There's a couple like notes I want to talk about, but otherwise, I want you guys to try 3 through 7. You can be shortcutted in your notation or in your description as long as you do the valid work. You can think about the absolute value, the convergence or divergence if you know it quickly, and that might be able to shortcut the process, or you can start as the limit as n goes to infinity and go the long way. Either way works. I'm saying on number 3, you could just shortcut and think absolute value. Why am I saying that? If we shortcut the process and look quickly at the absolute value, what conclusion would we make on this one? But why?
It diverges by P series test.
Wait a minute, do I know anything if the absolute series diverges? It's not absolutely convergent. Ah, stink. So maybe on this one, that wasn't a good place to start. Would the next one be a good place to start with the... Yes, because the next one, if I start right away with n equals 1 to infinity of the absolute value of negative 1 to the n minus 1, what can I say about that series since it's n to the 4th? By P series, P equals 4, which is greater than 1. And why is that good?
Because then it has to be convergent.
What kind of convergent?
Absolutely.
Yeah. So anyway, all that to say, every now and then we can save some time if we go straight to the absolute value, but every now and then it doesn't really save time because it doesn't necessarily get us to an answer. All right, you guys keep going. Let's see how we do 1 through 7. No, 3 through 7. We'll check them in a little bit. You guys can collaborate as needed. Kind of did 4. We did 4 entirely. Kind of talked about 3.